Calculus is built upon limits. So as you start learning calculus, it's really important for you to understand what are limits. So to me, the most basic explanation for a limit is where is the graph heading? I'll show you what I mean by that in a minute. We're going to look at one-sided limits, two-sided limits, and also limits as x goes to infinity. These are kind of the beginning, the basic ideas of limits, and it's really nice to start with a visual example. So starting off, I've got the definition. Limit exists, and this is referring to a two-sided limit. Limit exists if the limit from the left and the limit from the right are approaching the same numeric value. And here's a little notation you'll be familiar with. This here refers to the two-sided limit. X is approaching A. A is any real number on the x-axis. So as x is approaching A, and again this is from both sides, then f of x, also known as the y values of the function or of the graph, that two-sided limit exists if, now this isn't a typo, IFF is mathematical notation for if and only if, meaning that this is a sort of a back and forth conditional relationship. So this happens if this happens, and this happens only if this happens. So the two-sided limit as x approaches some real number a of the f of x function exists if and only if both of the sides approach the same numeric value. You'll notice I have limit as x approaches a with a little minus sign. That means from the left. And over here, the limit as x approaches that same number a, but with a plus sign. That means coming in from the right, or the positive side of the x-axis. And again, the limit, in order to exist, has to be a numeric value. Basically, you have to remember that infinity is not a numeric value, right? So infinity means that the graph is unbounded and going on forever and ever, up, 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 or down, down, down. So we're talking about a real numeric value. So let's take a look at a couple of examples. I start off with the cosine graph. This is a graph of y equals cosine of x. And this first notation, of course, is saying what happens to the graph as x approaches 0 with a little minus sign, meaning coming in from the left-hand side. What happens to the graph? Where's the graph heading? What is the y value looking like? So as we come in from the left, you'll see that the graph is approaching y equals 1. So we would say the limit is 1. Turns out, same thing from the right-hand side. As we look at 0 plus, as x approaches 0 from the positive side, or from the plus side, we are also approaching 1. So that point there is at y equals 1. Since both sides agree, and remember that was our definition, a two-sided limit exists if the left-hand side and the right-hand side are equal and they are the same numeric value. Well, 1 is a numeric value, so we would say that the two-sided limit does exist, and it is also 1. Next, let's look at limits involving y equals tangent x. So specifically, I'm looking at this limit as x is approaching pi over 2, both from the left, the right, and then from both sides. So at pi over 2, as you're familiar with the tangent curve, at pi over 2, we have a vertical asymptote. So the function itself is actually undefined of pi over 2. Well, as we come in from the left, from the minus side, as we come in from the left, you'll see that the tangent curve is just going up, up, up. It's getting closer and closer to that asymptote without ever touching it. It's in fact an unbounded curve. There's no top to it, so therefore there's no limit to it. So one thing you could say is this limit is approaching positive infinity. You're describing the direction that it's heading. But officially, we would say that limit does not exist. And the shorthand you'll usually see is DNE, for does not exist. Notice I didn't use an equal sign there. I used an arrow because we never can equal infinity because it's not a numeric value. Likewise, on the right-hand side, we're approaching pi over 2 from the positive side. So that's saying what's happening here as we get closer and closer to pi over 2 from the right. This time we're unbounded, but this is in the negative direction. The graph is unbounded, going down, 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 getting closer and closer to that vertical asymptote. So this time we could say that graph is heading towards negative infinity. We also would say officially that limit does not exist. Infinity is not a limit. You never reach it. So the limit from both sides, well, first of all, we don't have a numeric value. Second of all, they're not even going to the same place. Doesn't matter. If they were both positive infinity, the same thing would apply. Because these are not numeric values, therefore this overall limit, two-sided, does not exist. Next example I want to look at is one where x is going towards infinity. This is something you'd also refer to as end behavior. And I chose y equals 3 to the x power as our example here because it has different things happening in each direction. So notice here, I say the limit as x is approaching negative infinity. What does that mean? That means what happens with the graph, where's the graph heading, as x is getting smaller and smaller and smaller, off in the negative or the left-hand side direction. Well, 3 to the x gets smaller and smaller and smaller and smaller. It approaches 0. For instance, if you looked at, I don't know, when x is negative 100, well then y would be 3 to the negative 100 power, which is 1 over 3 to the 100th. That is teeny, 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 tiny. Practically 0, but not quite there. So as we go farther and farther out, these values get smaller and smaller, closer and closer to 0. And in fact, what occurs here is we end up with a horizontal asymptote. And in this case, it is at y equals 0. So the limit as x goes to negative infinity equals 0, and therefore we have a horizontal asymptote at y equals 0. Now, on the right-hand side, as x gets greater and greater, closer and closer to positive infinity, you'll notice that rather than approaching a limit, the graph is going up, 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 and will be unbounded. Imagine something like when x is equal to positive 100. Well, then y is 3 to the 100th power. That is ginormous. So this graph, as x goes to positive infinity, this graph is unbounded in the positive direction. So once again, you can say it is heading towards positive infinity. That's the direction it's heading, but you also should add that officially that limit, d and e, does not exist. Next, let's look at this graph, which has got all kinds of crazy things happening on it. First, I want to look at the limit as x is approaching 0. And you'll notice by the notation here, I have the limit as we approach from the left, from the right, and then this one, of course, is from both sides. Now, as we approach from the left, you'll notice as x is getting closer and closer to 0, the graph is getting closer and closer to the y value of 3. But there's a hole there. So does the limit exist or doesn't it? It turns out it does not matter whether there's a point there or not. We're really looking for where is the graph heading. So even though there's a hole there, from the left, the graph is definitely heading towards y equals 3. From the right, x approaches 0 with a little plus sign from the positive side. We are approaching y equals 1. So this limit is equal to 1. Now, we know that the definition of a two-sided limit is that the left and the right-hand sides have to agree and have to be the same numeric value. While they are both numeric values, 3 and 1, they certainly are not equal. So actually, what we would say here is this limit does not exist. Next, let's look at what happens on this graph as x is approaching 2. Well, from the left-hand side, here's 2. From the left-hand side, you'll notice that the graph is going up, approaching a vertical asymptote, but definitely unbounded. So we would say positive infinity and does not exist. Likewise, from the right-hand side, we're going up, 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 unbounded, also heading towards positive infinity, does not exist. And since neither of the right-hand or left-hand side limits are approaching a numeric value, then we would say that the two-sided limit does not exist. When we're looking at the limit as x is approaching 3, which is right here, you'll see from the left, we are approaching this hole in the graph, and that hole is at y equals -1. So we would say from the left, we are approaching -1. Remember, The point doesn't have to be there. It's just where is the graph from either side heading. From the right-hand side, from the positive side, we are also heading towards y equals -1. And since both the left and the right agree, our two-sided limit also is approaching -1. Next, let's look at the end behavior of the graph. That is what's happening as x is approaching -infinity, going off to the left, and what happens with the graph as x approaches +infinity, meaning going off to the right. Well, as we go off to the left, you'll see that the graph is getting closer and closer to 0, and it appears to be approaching an asymptote. So in this case, visually, we would say that f of x is approaching 0. And we would say that y equals 0 is a horizontal asymptote on the graph. And then going off towards the right-hand side, as x gets bigger and bigger, we see that the curve is getting closer and closer to this horizontal asymptote at -3. So y equals -3 would be the asymptote, -3 would be the limit. So as you proceed in your calculus course, you'll find that limits can be used to identify all kinds of discontinuities like jumps and holes in vertical asymptotes, and like we just looked at, end behavior including horizontal asymptotes and unboundedness. I've got more videos on more complicated levels of limits and also all my handouts. You can see them on my website, which is commonsensecalculus.com.